Hello. In this video, we are going to learn how to calculate determinants of matrices. But before we can learn how to calculate them, we first have to learn what a determinant even is. So a determinant is a special number that can be calculated from a square matrix, meaning the matrix is to be a 2 by 2, a 3 by 3, a 4 by 4, a 5 by 5, a 6 by 6, etc. A 3 by 2, a 1 by 4, a 7 by 8. Those are all examples of non-square matrices. Therefore, the determinant is undefined. It does not exist. Determinants are important because they allow matrices to be much more useful. They allow us to use them for programming and different things like that. But today, not today, but soon, we're using determinants to calculate the inverse of different matrices. So that will be coming in future videos, so be looking out for that. So first, we need to learn how to calculate the determinant of a 2 by 2. So I've given you this general matrix, A, B, C, D. And we're going to talk about the process. You're going to multiply from left to right. So A times D, and then you're going to subtract, and then multiply from right to left, B times C. Your answer will always be one number. Okay, let's look at an example. So I gave you the matrix 2, -1, 3, 2, and I'm asking you to find the determinant of it. The first thing we need to do is multiply from left to right. 2 times 2. Subtraction, always in between the directions. We always subtract in between the directions. And then -1 times 3. Let's simplify. 2 times 2 is 4. -1 times 3 is -3. But a negative and a negative make a positive. So 4 plus 3 is 7. That is how you calculate the determinant of a 2 by 2. Let's learn how to calculate the determinant of a 3 by 3. We have the determinant A, B, C, D, E, F, G, H, I. Now, a determinant of a 3 by 3, there are all kinds of different ways to calculate them, but I'm going to teach you one way in particular. It's called SAR's rule. And it's a little shortcut because if I taught you the formula the way we just looked at a 2 by 2, it could be very long and have lots of room for error. Now, there are also other methods that I'm sure you could find if you search determinant of a 3 by 3 on YouTube or on Google, but this is the method that we're going to focus on right now. The first thing we need to do is we need to copy our first two columns outside of the determinant. So we're going to take A, D, G, B, E, F, and copy them outside of the determinant. Now we are going to start multiplying from left to right. A, E, I. Okay. Now we still have a lot more diagonals, so we're going to add, and then B, F, G is our next diagonal. And then we're going to add, and then we're going to multiply our last full diagonal going from left to right, which is C, D, H. Okay, if I look at this determinant, I no longer see a full diagonal going from the left to the right. I see two diagonals. I only have 2 elements in them, but I need a full diagonal, so I need 3 elements. Since I don't see any more diagonals, I'm going to move and go from right to left. C, E, G is going to be our first diagonal going from right to left. Then we have A, F, H. And then we have B, D, I. So I want you to notice that we added. Whenever we were going in the same direction, we added, whether we were going from left to right or right to left. But if you paid attention or if you caught onto this in the previous slide, determinant of 2 by 2, I told you that we were always going to subtract between directions. So AEI plus BFG plus CDH is going from left to right. CEG plus AFH plus BDI is going from right to left. Those are 2 opposite directions. So between these 2 directions, we are going to subtract. Once you get finished, your answer will be one single number. Let's look at a concrete example. I gave you the matrix 1, 0, 3, 4, -1, 6, and 2, -3, 1. Our first step is to take our first 2 columns and copy them to the outside. Now we need to start multiplying from left to right. 1, -2 times 1. Next is 0, 6, 2. I'm still going in the same direction, so I'm adding, And then lastly, we have 3, 4, negative 3. Once again, we see that there are no more full diagonals going from left to right. So now it is time to switch and go from right to left. My first diagonal is 3, negative 2, 2. Going in the same direction, so I'm going to add. And then multiply 1, 6, negative 3. And lastly, 0, 4, 1. Now, in between the two directions, I'm always going to subtract. I need to simplify this. 1 times negative 2 times 1 is negative 2. 0 times 6 times 2 is 0. 3 times 4 times negative 3 is a negative 36. So instead of saying plus negative 36, we just went ahead and switched it to minus. In the next group of parentheses, we have 3 times negative 2 times 2. It's negative 12. 1 times 6 times negative 3 is negative 18. So now we have a minus 18. 0, 4 times 1 is 0, so plus 0. And in between directions, we subtract. Negative 2 plus 0 minus 36 is a negative 38. Negative 12 minus 18 is a negative 30. Once again, in between directions, we're going to subtract. And negative 38 plus 30 is, or negative 38 minus negative 30 is the same thing as negative 8. So that is how you define the determinant of a 3 by 3. Determinants of a 2 by 2 and determinants of a 3 by 3 are going to remain critical as we move forward in defining inverses of matrices. Stay tuned for the next video, or tune in, not stay tuned, tune in for the next video as we investigate how to calculate the inverse of a 2 by 2. See you then.